seen on the submission website that many people have already gotten I wouldn't say many, I haven't counted, so I know people have gotten 100%. So for those of you who think it's not possible, it's possible. So that's that. And clearly you think it's possible, otherwise we would have many more empty seats in this room right now.
Yeah, I only got 9 out of 100 because I didn't pass the turn case thing.
9 or 90?
90 out of 100.
You gotta turn a key correctly. You gotta turn that key. Yeah, that's the only one that actually tests that, so yes.
So when you submit like a smoke test for grading, you get like 100 of those submissions, right?
Yes, 100 smoke tests, so you can keep doing that. Well, don't just keep doing it, because then it gets stuck in the queue and then more people can't actually do their stuff. So, but yes, the idea there is to just make sure it compiles first before it actually, like, you submit it for real. Cool. All right, so let's get on to access control. So we talked about what's an ACL, besides something that my football players keep tearing, my fantasy team, and my real team, I guess. It's an access control list. So what is an access control list? Was more specific than who can access stuff. You can answer that to almost anything in this entire access control section.
Users get specific permissions.
Users get specific permissions to do what?
Do whatever the system.
Okay, so specific permissions, specific rights. But how does an access control list contrast with a capability list or with a access control matrix?
What is it? Capability lists? Capability lists are more like based on the rights in which users can use them, but it's the opposite for access control lists, right?
They're all, well, okay, yes. So they're all about who can do what.
Yeah.
The difference is capability lists are stored with the users, right? Every user has what files and what rights they have on those files. Whereas an access control list, every file or object in the system has what users or what subjects can do what on that system. Yeah, cool. Awesome. So Unix, so we spent a while, actually it was really annoying. Now every time I SSH into that server, it's still running bin sh instead of bin bash, and so it's, I still haven't changed it back. Every time I do it, I realize like, oh, this is why you shouldn't change systems you actually use, because it's kind of annoying. But anyway, so we went over the Unix access control list. So we talked about that Unix has, so someone kind of refresh our memory of what we talked about how Unix does access control and access control lists. At a high level, you have to do everything right off the bat, yeah.
So it uses metadata correlated with the file.
Uses metadata, so for every file there's some metadata. You can see here it's actually just 12 bits per file, which is a pretty low overhead. What do these bits mean? They mean 1 or 0, yeah.
Read, write, execute for the owner, group, and row or other.
Right, so read, write, and execute for owner, group, other. How many bits does that get us? 9. There's 12 bits. What are these last remaining bits? It's magic bits.
SUID bit.
SUID bit, which is what we saw was the SUID bit do. So it runs the process as the owner of, so when you execute that file, it runs the process as if it was that user. Set group ID, so that's another one we didn't talk about. That's the third one. Second one, and the third one is, anybody know? Sticky bit. What's a sticky bit? Yeah, it's normally on directories, anyone who has write access to that directory can delete files. But in some directories, so what directories would you want? Do you want, so think about this, what directories do you want any user to be able to create a file in?
Temp.
Temp? Why temp?
Because it's temporary space.
Yeah, it's temporary space. It's made for anyone to be able to write a file. Do you want users to be able to delete other users' files out of the temp directory? No, definitely not. So that's why the sticky bit was born, so that way, and I think it has, the other thing is, these all mean something slightly different. So we talked about this of the owner, users, and all users on the system. So owners, users, all users, read, write, execute. For files, it's very straightforward. For directories, it's slightly more complicated. But we won't go into all of that. Cool.
Wait, SUID stands for super user ID or something?
Set user ID. So
Set
it means
user ID.
set the user ID of the process that runs based on the owner of the file.
Okay.
Whereas the set group ID says set the group ID of the file based on the group of whoever the group is of the file.
And the sticky bit is some kind of like, sticky bit is some sort of like flag bit or something?
The sticky bit, so these are the bits basically. So you have three groups of three. The first three, set UID, set group ID, sticky bit, read, write, execute, owner, read, write, execute, group, and read, write, execute, all. Actually, if I remember correctly, the sticky bit started life out on a file. So if a file had a sticky bit, it meant that it would always be kept in memory and it could never be swapped out. Because for some applications, swapping it out would either break it, I guess, back in the day. But I think that's not used pretty much anymore on files, but it's used on directories for that reason. I just remembered that. So look it up, the sticky bit Wikipedia page, which you can learn everything you've ever wanted to learn about the sticky bit. Cool, yes?
Is it possible under this scheme to have the root user unable to do something to a file?
So it's a good question. So I guess a higher level question is, why would you want the root user not to be able to do something on a file? So maybe as an example of kind of least privilege, so you're saying that restrict even the administrator's abilities to do stuff. What else? Yeah.
There's more than one root user?
Good idea. On most systems, no. You have multiple users, which is actually a huge problem. So you have a bunch of users on the system, they can each become root, and so that actually is a problem because you want to know which administrator did what on the system. Yeah.
There was that web server example where root is the only one that can open up a port for the web server. So maybe you don't want people using that.
Right. So yeah. So the high level idea. So with this, so what does this allow? Like if you think about this in terms of like an access control model, what types of access control can you specify? Yeah.
Are you trying to get it that it's not too fine grained?
Partly, but I want us to explore the bounds of this of this model. So like, what are some things you can say in this model?
Give everyone access.
Who can give everyone access?
The owner of files.
Right, so part of it is the owner of the file can choose who to give access to in these concepts of owner, group, and all. Right? Who else can change the permissions on a file? Root. So is there any way in this model to say that root can't read a file?
No.
How would you try to do that?
Not give them read permissions.
Right, so create a file that only you own and give it read-only privileges to you and no other privileges to anyone else. But does that mean that nobody else can read that file? Why?
Because root can change the owner.
Right, because root can change, not only, so that's a good point, root can change the owner of the file to themselves and read it, or root can change the permissions of the file to give themselves read access, or they can even become your user and then read the file too. Would it be useful? Why would you, so we just talked about that actually, so it would be useful to do that. What are some of the things that you can't express in this system that we may want?
Yeah. Express like a specific user or something?
So to give, just to share access, so you think about anyone use Dropbox? Yeah, you can do things like share, anyone who has the link to this file can download it, which is pretty cool. You can't really do that on a, could you, I guess, okay, that's a good question for you rather than me. So how could you do that in the Unix model?
You could make like a public user or like a group and like give people access to the group that has access to the file.
But they need, so in this model, it's if you know, so if you think about the link is knowledge of the location of a file. So if you know about the location of the file, then you can access it, but you can't access it otherwise. So specifically with a link, do you have to go to the owner of that file to view the file?
No.
No, what do?
You get the link.
You just get the link, you click on it, and now you're viewing that file. So it's anyone with the link, which is exactly similar to what kind of access control model that you're implementing now in your homework. Like a key, right? So as long that link is the key. If you have that key, you can access the house, you can access the file. It doesn't matter where you got it from or who gave it to you, you can still access it. So can you do the same thing here?
No.
What would you need to do that? What properties do you need to hold to do that?
What keys can access this file?
Yeah, so you need some way, so what's the core idea of a key in this case?
There's a lock.
Could be a lock. The lock is a little misleading, so we don't have any lock in this case. Huh? Kind of similar to a password. So what do you want with a password? Yeah.
To authenticate the person?
You want to authenticate the person? True. Let's think about Dropbox. How does Dropbox do it? When I want to share this file with somebody, I can just say, share this link. Anyone not done that before? So you share a file, right click, share it, creates a link, you give them a link, and they can now see that. How does that work? How come other people can't see that file?
Because it's not public access.
Because it's not public access, but how do they actually ensure that? It's just a link. It's a URL. Yes.
Each URL is probably randomized
Yes. So randomize. Why is randomize important?
because randomized suggests that there's no way to properly encode it without a lot of time and a very advanced hardware.
Right. So assuming it's random enough, which we'll get to when we talk about crypto, it should be impossible for somebody to guess it. If I just create links that the first link is 1, the second link is 2, the next link is 3, is that a secure, good mechanism?
Yeah.
No, because somebody could just enumerate all of those numbers, get all the files. It should be, you have to have knowledge, you have to have this link in order to view the file. And in this case, the key would be that random string of letters that you need to guess. Can we do the same thing here? Yeah.
Yes.
We can make a really complicated folder directory system and then just make it world readable.
Okay, so we can make a really complicated file directory system. So we can maybe make in our home directory have like a shared, and then what would we need to actually do this? This is a fun exercise.
Competent users.
Competent users. We are the competent user. We're creating it in this case.
Are we the only ones that have access to it though?
Say it's a shared system. So it's a shared system. We want to be able to create a link, in this case, a file that we can share with only people who know the location of this file. So why don't we just create a, well, I don't know, what do we need to do? Okay.
Could we like password protect it?
How do you
gen-
password protect here? You can only use these things. So we're
Okay,
only
could
working
you-
in this model of this Unix access control. Yeah.
You could make, so you could, I guess you have to make the file world readable.
Okay.
Everything
you need
else-
to- the file would
yeah.
need to be world readable. Why?
Because if you want to share the link, or in this case, like the directory, it has to be able to be read by everyone.
Okay, so fundamentally, the file itself must be read by all. Does that make sense? Because otherwise, people would have to ask us, the owner of the file, to get access by adding them to a group or whatever, which we just said we don't want to do. But if I just create, let's say in /temp, I create a file there that's world readable called my super secret file I want to share, that's world readable, what does that mean?
Everyone can see it.
How can everyone see it? How do they, like, walk me through the steps? So you're another user, how do you see this file?
Go into the temp directory.
You go in, you can do cd/temp, and then what?
LS.
You ls, so you list all the files in the directory, and then what do you do?
CD.
cat the file. Yeah, you cat out the file, right? The file. So we need the file to be world readable, but what else do we need? Yeah.
Could we make it hidden?
Make it hidden? How do you make it hidden? You can only do this. You can only change these. Yeah.
Maybe I would make it world readable, but also make it. It can't be password protected, but it has to
Correct.
be world readable,
Correct.
and it has to be in some part of the directory that's somewhat hard to get to.
Okay. So think about that. So think about if we walk through those steps, right? So we put it in the temp directory. What was the problem?
Someone could find it.
Say that again. Public in what sense? Specifically, what can somebody do to the temp directory? They can see what's in files. They can list all the files in the directory. Which of these permissions is this on a directory? Read. So a read permission on a directory means that you can list all the files in the directory. What does a write permission on a directory mean?
Create files.
You can create and delete files, I believe. What about the third one? Execute. Yeah, what does execute mean?
You can change your directory.
You can, not quite, well, actually I don't know. That may be right, but you can access subdirectories of that directory. So what would it mean for a directory to not be readable, not be writable, but be executable?
You can.
Like,
Oh, you can access subdirectories if you know what they are.
you can access subdirectories if you know what they are. So how does that help us get what we want to do? I'm gonna bring out my.
You can make a subdirectory with it.
You can make what?
You can make a subdirectory with
What would you want that subdirectory to be?
like a weird name.
Like, not just weird, how weird?
Super weird, random weird.
Super random, super weird, that's unguessable. So you can create in your home directory, and I'm going to swap it out into here, good. Oh. Is this big enough? Can you see my hello? Okay, so let's say we have a directory. So we have home, Adam D, that's us, we're the user. So now we want to create a directory called, let's say, shared, and we have our file. Did I spell that wrong? I'm just gonna call it toShare. So we have our file toShare. So we have our shared directory. What do we need to do to be able to create a place this toShare file in a place where we can share it with people with this? Yeah.
We should make a random directory inside of shared.
Okay, so make it random. So we'll do cd. That's super annoying. So cd shared. Mictor. I'm just going to call it random like this. So we'll assume that this is. We'll insert some super random thing here that can be as long as we want. So it'd be super unguessable. Now what do I need to do? Okay. Do what? Say it.
Is it CHMOE?
Yeah. What do you want to do?
Executable? Yeah.
Well, I want everything for me. And for my group, I guess that's fine too. So you want it to be 1, so just executable on that? We'll do 711. Yes. Yeah.
Don't you want random to be readable, but the parent directory to be executable?
Mm.
Because you want to be able
What
to
does that
go
mean?
into random and see what's in it.
I don't know. What do we want to do?
Because we don't want to see
Mhm.
the random directory from the parent directory, because that
Mhm.
defeats the purpose of what we're trying to do. But
Correct.
once we're in random, that's like the link that we've just given out. So they should be able to
Alright.
see the files that are there.
Okay. So you've convinced me. So then what do I do?
I don't know. I don't know which number that is.
CD dot
I think it's
shared.
read is. I think it's 5.5, isn't it?
That's read and execute.
Read and execute.
Yeah, so 4 would be just read.
Okay. But we need them to be able to go into any subdirectories possibly. It's not going to change it too much. We can also do, if you're so inclined, we can do chmod. Actually, I don't remember the syntax, but the owner, read write, execute. Actually, I don't know how to do this, so translate at your own peril. Okay, then what do I do?
You want to move the file into the directory.
So yeah, let's cp whatever from to share into random / to share. Now what do I need to do?
Set permissions on that.
I need to set permissions on that. What do they need to be?
Readable.
World readable, right? Yeah. So we can do 7.7. What did we say was 4? I think that's right.
Just read.
Sure.
What was that? Just read? Yeah. So do we want them to be able to delete the file?
No.
Probably not execute the file. I mean, it depends on what it is, but normally not. Cool. And what do we need to make sure? So now we have /home, Adam D, shared, random, to share. So what do we need to ensure about this directory structure? Yeah.
Well, we need to go to share to make sure that it only has execute permissions for everyone and nothing else, so they can't read or write.
So I need to make sure that my directory permissions on shared are, so me, I can do anything. My group, whatever, I can also do anything. And what do I need these permissions? So do I want to do 7 as well on shared? What's this going to mean that people can do?
Read, write, and execute.
Yeah, I can create directories or specifically list the shared directories, see all my random values, and then go check out all my files. So what do I want here?
Just be 771.
Just execute, right? So that this way somebody can change into a subdirectory of shared, but you can't list shared, so you can't actually see the files there. So what else do I need to ensure about this entire path? What if my permissions on my home directory are 770? Yeah.
You're gonna want to make your home directory also at least 771, so people can navigate to the shared folder if they know.
Right, you want your home directory to also, you need actually every directory above you needs to be at least executable so that somebody can change directory into there. And if we do this, now we have a link that we can share with anybody on this system. They can copy this file. Anyone with that link can copy the file, but we cannot copy that file. Kind of crazy, you just implemented an insane mechanism here. Yeah.
So you have to leave the one. Could they use the entire path and just CD to that place if the previous directories like home and Adam were both 0 in the chmod?
They cannot at all. So if they're 0, it means that you can't even go to any of the subdirectories, even if those subdirectories allow you to do so. And even if you know the exact name, it'll say access denied. Yeah.
What access do the user need to have to LS?
To LS, they need read permissions, I believe, on a directory. Yeah. And that's what this whole thing is based off of. So the whole idea is the security there is basically ensured by, what is it, here? Wait. Here, shared. So making sure that shared is not readable by everyone, because anyone who can read that directory means that they can list all the files, which means they can see those random values and then see the files that we have, which is the entire thing we're trying to prevent. So with this, nobody knows what this random value is until we send them this link and say, here, copy this file. I mean, it's a link, quote, quote, right? But once they have this path, they can copy that file to their own directory. But without that, there's no way they can guess unless they can guess this random value. Cool. You just implemented a really cool access control thing in a system that seems very restrictive. Who, although we said nobody can see this file without how link, but is that actually true? Who can see this file? Root and who else?
The owner.
The owner, me.
And the group's owner.
And the group's owner too, we'll assume the group is just me, and so it's all Adam D here. So yeah, super cool example. So it's important to remember that because people often forget, and we've talked about that before, people forget that administrators on these systems have access to all your files. So do not store sensitive stuff. Cool. Okay, so the idea here and the things that we were talking about was, can we restrict root permission here? So with this, is there any way in this system to restrict root's access? No. But we decided we wanted that, so you'd have to extend this system and add additional features to it, which is exactly what modern systems do. So yeah.
Are we assuming that like cryptography doesn't exist? Like
No.
GPG? Because this could have been achieved in a much less roundabout way with just GPG.
That assumes that the users know GPG, because you could get that same thing with Dropbox by doing that,
Well,
but
yeah.
Dropbox
You could-
specifically doesn't because of the UX problems.
You could give them a link, which is just a shell script that decodes it, like decrypts the file with a key.
Ooh, you're going to give them a program to run, and they're going to trust you to run it?
If they don't know how to GPG, they're probably going to trust anything I say. So.
That's probably true, but yeah, the idea was using this model, and I'm actually, well, I'll maybe describe in a second. So I actually was in a case where I wanted to do something like this. It's kind of a long story. Anyways, let's say I wanted to prove that somebody on my system ran specific code that I gave them, but I didn't know which user it was going to be. So what I did was I actually created exactly this same structure that we just talked about. So I created this structure, put a file there, had my code log to this file who did this, and what the user was that ran it, and that way I was able to see which user executed it, because the only person who should write to that file, because nobody would know what the actual location of this file is, you'd have to actually run the code in order to see that. So that was a fun story. Maybe I'll tell the full version some other time. But it does, I mean, there are crypto parts here in assuming that we actually have a random value. So modern systems actually include the ability to do things like you can make a file immutable, which means nobody can change it, not even root, except that they also have the ability to make it unimmutable. But they have to do that first before they delete it, so it's a nice kind of extra step. What are some other things you can't express here that you would want? Yeah?
Maybe like a time when they can access?
A time. So maybe saying something like, I'm going to release a homework assignment at midnight tonight. I want you to have access to this right then and not at any other point. You could kind of do that by creating a cron script that's going to do the chmod when you want, but it's still a huge pain, and you're not. This system itself doesn't guarantee you the ability to do that, right? Which could be something you want. What else? So what does it mean when somebody, so do you want to have files that, what does it mean when somebody has write permissions to a file?
They can delete or...
They can delete or append to that file. Would you ever want a case where somebody can just append to a file? And why would you want that?
Maybe a project someone's working on, like multiple things.
Maybe a project where people are working on multiple things. What else? Yeah.
Maybe if it's like a log file, you just want to append like the latest results rather than change it or delete it.
So a log file. So why are log files important? Do we care? Yeah.
To see who's accessing it?
See who's accessing your system, to see what every process on your system is doing, what your services are doing when you're submitting homeworks, and for whatever reason, some of you keep getting into weird corner cases that I somehow have not hit in like I don't know, many times I've been doing this course. I have to dig into the logs to figure out what the error is and how to fix it, because otherwise I don't know what's going on. If you're thinking from a security perspective, if you're having logs of who's doing what on the system and what's going on, you want to review those in case there's ever an incident or an event. So the integrity of those logs is pretty important, right? So would you want the process that's writing to those logs to be able to wipe the logs? No, why not? It defeats the purpose of having those logs, because if a bad guy or an attacker infiltrates your system through that process, what they're going to do is they're going to clean up their tracks by just deleting those log files. So you'd want the process that's creating the logs to only ever add entries to the log and never be able to delete them, which is kind of nice. So there's another way and I don't remember all the details, you'll have to look it up. I want to say it's at the like ext4 level that adds a lot of these features, not like Unix itself, but yes, there is a way, because is there any way to express in here that somebody can just append to a file? No, there's fundamentally no way. So this is something that this access control model cannot express. And so we need other ways of doing that. So there's a method where you can actually do that. Any other things that would be, you think, useful from a security or system administration perspective that this model does not allow you to do? Anyways, time is a cool one. Maybe time in terms of letting you have access to a file only for a certain amount of time. What about, would you like to know, say, only this user can access this file, but they can't let anyone else access it?
Being able to write to a file, but maybe not copy it.
Being able to, ooh, that's a good one. So being able to write to a file with, that's interesting. I don't know if you can express here writing without reading. I know you can open a file for reading, but I think it truncates it. I wonder if you can open, maybe if you set the file to append only without read, you could have a file that you wrote to without reading. Cool. These are all fun things. So, and this actually gets to kind of other ideas in access control. So access control is, you're not just limited by these kind of capabilities or these models that we've been talking about. So content-dependent controls. So think about like a salary system. You may want to give people access to some data depending on what that data is. So for instance, like, let's say, yeah, okay, so this is good. So like you can see, so in your corporate system, you can see salaries of the people that report to you. Is that important as a manager?
Yes.
You're managing these people, you don't know how much they're being paid, you don't know if you should be fighting to get them more, get them raises, whatever. But should you be able to see everybody's salary in the company? It depends on your viewpoint, but usually that information is kept a little bit more private, unless you're a university. And so you can think of like controls that depend on what the actual content is. Another way of what you got to when we were just talking about this is basically context-dependent controls. So what are some other interesting contexts besides like a temporal time context? Yeah.
Maybe like for the submission server, maybe we only want people to access the thing that runs it only 20 times.
Okay, so that's interesting. So context in terms of past actions, maybe. So maybe the actions that you take on the system restrict your access. That's a great idea. Or like give you all unlimited submissions the week before, but as you get closer and closer, your number of submissions goes lower and lower. Or increasing a time delay between submissions. These are all things I've considered, but have not yet implemented. What else? What are some other interesting?
Number of concurrent sessions, maybe viewing a file.
Okay, so context in terms of number of concurrency type issues there. Yeah. What else? At a certain location, so when would you need to know somebody's location? No, I mean, when would that be useful in terms of like access control and granting access to the file? Yes, or there's was the case of the person, I think they were working at Yahoo, and it completely outsourced their job to somebody else, so they just like passed the job to them, which is like completely circumventing the corporate firewall and the VPN system and all this bad stuff. Think about, so should your health records be like publicly available? No, definitely. I mean, there's HIPAA requirements, there are legal requirements that say your health records should not be public. But who should have access to your health records?
Doctors.
Doctors.
Medical insurance people.
Insurance people, maybe. Depends on what the specific circumstance is. So you think location, should a doctor, like, I mean, how, so when you think about location, I think like, well, does the doctor need to see your medical records when they're at home? Maybe, maybe not. It kind of depends on what they're doing. When they're in their office, or when they're in the operating room and you're lying there on the table, right? So their location can actually help you make a really informed decision and say, well, just give anyone who needs access to it in the surgery room, whatever they need, just give it to them, right? And deal with it later, which is kind of how it works normally. So yeah, so remote login, the context in terms of time. So time is the other big one where you only update things at certain times. And we talked about the corporate earnings report. So these are super confidential until they're publicly available by anyone on earth. And so there it's not important anymore. So these are all kind of interesting aspects to access control when you think about that. And so yeah, these are very cool. Questions or other thoughts, ideas around this topic?
Wait, not all context-dependent controls are time-sensitive, right?
Correct. Context would be really broad in terms of, it depends on whatever you want. So it could be time or location or, I don't know, maybe you could think of like corporate restructuring or something. Maybe you just bought another company and you're merging, so you have weird rules that are only in effect first while that process is going on. Cool. Awesome. So, in the model that we've been talking about a lot, in the UNIX access control list model, who decides on the access control policy for a specific file? Yeah.
The owner or root?
The owner of the file or the administrator of the system. Is that always what you want? Why? Excuse me, why not? It seems silly. I own this file. Why don't I get to control who gets to see it? Yeah.
Well, I mean, assuming if you're a very bad person and or you're getting blackmailed or something, you could let some bad people see the file.
Yep.
That's kind of illegal.
So what, like, okay, so it's illegal in what context? Or it could be illegal in what context?
Alright, say it's a company's financial reports, and you let someone see it, and they see where you're investing your money. And then when they see where you're investing your money, they can reroute it to go straight to their bank accounts.
Yeah, or you think about the example of the corporate earnings report. Who writes that report?
Bunch of analysts.
I don't know. Well,
The CFO at least.
at least the CFO, right? Or they're the ones who rubber stamp it, right? So people in their organization, you can think of it even goes down to like maybe a low-level accountant or whatever in the firm, but they're writing this report. Should that person just be able to publicly release that information? No, right? That could actually have serious financial consequences on the company. Yet, they're the person who wrote that data and created that data. What about the military? Do they think that whoever created the data or the file or owns the file should be able to do whatever they want with it?
No.
Why not? Or some counterexamples.
I mean, like, it's the military. Their command structure is shifting all the time. If only Navy controls like a certain portion of the files, and like they don't want the Army to access it for some petty reason. That could be
Interesting.
damaging down the line.
Yeah, so you may have inter-organizational conflicts, yeah.
Someone does an analysis of some system and then you know, it's a confidential report and maybe they're an outside contractor or something, they pass it off and then, you know, they don't want that user to be able to go back in and just say, oh, I'm going to go publish these on WikiLeaks.
Right, or spies, right? Spies write intelligence briefings or reports about what's going on. Does the government want that information public? No. Otherwise, they would make it public. And so this is actually, so when we think about access control models, we kind of start classifying them into different areas depending on essentially who can do what or who decides the access control policy. So if you think about a Unix system, who decides the access control policy for a file? We just talked about it. The owner, right? The person that created that specific file. So in some sense, so this is what is called a discretionary access control model, where essentially the owner of the file gets to choose kind of what happens to that file and what the permissions are. Contrast that with what I think of as the military model, and we're going to use that because it has a lot of really good analogies that we can kind of use, and it also drove this whole field of mandatory access control and thinking about these things in more formal terms. So that's mandatory access control, where basically, rather than the owner deciding, the system controls access to an object. So the system or the model itself decides who can set the access control on an object, who can change the access control on an object, which is very different than the way we're thinking of this Unix model. The root doesn't set the permissions on every single file. They can change them, but fundamentally every user can change the permissions of the files that they own. Yeah, question?
I was going to say, how do you avoid like a Skynet type situation where like the system just says, all right, screw admin, you don't get to access anything, you can't change anything, I'm going to delete all of your files for some random reason. Like,
well, do computers accidentally delete our files for random reasons?
Yeah.
All the time? Yes.
But my point is if system has the highest level of control,
yes,
and there's controls that root can't do, like how do you regulate, who regulates the system then?
Exactly, so that's a good question. Who does regulate the system, or who controls the system?
I mean, the manufacturer at the time that the system's made.
Exactly.
Then
yep.
Going forward.
So it all depends on what you're relying on this system for. So you may, for instance, demand access to the source code of that system so that you can verify that it's actually doing what it's doing. Or you can use something that's well tested. So there's, so basically discretionary access control is the Linux model, but Linux actually has a mandatory access control system called SE Linux. I believe it stands for Security Enhanced Linux. This allows you to write policies that cannot be changed. So you can say something like, this user can only access this directory. It doesn't matter what other things say. So in that sense, if you're using that, you're trusting that that system is actually implemented correctly. Yeah?
Do you run into resource concerns if you end up in a situation where you want to change the access control? Like
for sure. So we
scrap your whole system.
Exactly. We just talked about the log problem. So if you just have a process that appends to a log, what happens if that log grows so big it uses up all the hard drive space? The system locks up, like it's super annoying, right? So you need to have something else that can like deal with that situation, right? So yes, it becomes very complex. But both of these have in some notion this idea of owner. So discretionary access control has the owner of the object controls what happens to the object. But in a Unix system, what happens when I give you, let's say, access to a file? What can you do with that file? Like if I give you read access to that file, what can you do? Yeah.
You can copy it?
Yeah, you can copy it and then do what? And now who owns that file?
You.
The person who copied it, which now in this model, they can do whatever they want in terms of access control. So can you think of any systems where the originator of data would like to control access to that data? Yeah.
Maybe if it's like a confidential report, you want people to be able to like, your editors or something to read it, but that you don't want them to like publish it.
So for the confidential report, yeah, so you may have, Or, I mean, this happens literally all the time, and most corporations would love to have something like this, so that, have you ever seen, like, news leaks of, like, the latest CEO's email that they sent out to their company? Like, those are basically immediately public, even though technically it's an email blast to the entire company, and people shouldn't be releasing, like, those emails, but they do anyways. So if there's some way for the originator, like the person who creates an email, if there was a way to just limit the recipients to only those people, that would be useful. Are there any other instances of that?
Of like someone trying to send out something where other people.
Yeah, or even email in general, like being one of the fundamental properties of email is you can forward it to somebody else, which in that case, you may or may not want somebody to do that. You can even think of this in terms of, yeah. And so the idea, the key difference here is it's very similar to discretionary, but the idea is if the originator of the object controls who can access the object. And why is this difficult to do in practice? Yeah.
Because if someone can see the file, they can copy it. Even if the system doesn't allow them to, they could like hand copy it.
Right, or they take a picture of the screen. Anybody take a screenshot on their phone to send a text message to somebody?
Yeah.
Yes, right? You're essentially turning a text into an SMS, into a JPEG or picture, PNG or whatever, doesn't matter, and then sending that to somebody else, right? So you're fundamentally circumventing that, yeah?
And there's also the fact that the originator could be fired from the company, or...
Yep. Exactly, yeah. So people, I mean, this is a big problem that they would like. Or you think about when you watch a Netflix show, does Netflix give you the right to make your own copy of that show for your future viewing?
Technically, yes. They allow you to download onto your phone.
They do allow you to download on your phone or your tablet, but can you download it onto your laptop? No.
You might be able to with the app. But
definitely not legally.
But like they can't, you're not technically allowed to download and distribute. But
What was that, say again?
Download and distribute, but people can still do that.
Right, so as part of your agreement with Netflix, I'm sure if you go through the privacy policy, it says you're not allowed to download that, or yeah.
Steam does something similar for their games,
Mhm.
but that's more to like what Sid was talking about, where it's encryption with
Mhm.
Steam, where they're encrypted in such a way that you have to connect to Steam to unencrypt the game files to run it.
Exactly.
But it does stop you from, or it is a step to stop you from unlinking the files from Steam and just distributing them. And
Exactly. And so those are all kind of mechanisms of how you implement something like this, like what you want. But yeah, in all these cases, right? Steam where you're downloading video games, or anything where you're downloading, or music with like a streaming music. All of these, the originator of that content, well, I guess in this case it would be whoever owns that and is distributing it to you, wants to restrict what you can do with this, right? For Netflix, they want to restrict it so that you can only download it on an approved mobile device and only with their system, and you can only view the file on their system, and you can't just make a copy for yourself for backup purposes or whatever. And so they would love to be able to do this. This is like every corporation would love to be able to restrict this access, but as we just talked about, this is an incredibly difficult problem. And actually there was a paper, there's a research paper a while ago called Movie Stealer, where the idea was, their fundamental premise was it doesn't matter what DRM or whatever you're doing, at some point the bits have to go to the graphics card to be able to display it on the screen. And so if you can automatically identify in the binary what buffer is doing that, you can just grab the images from there and turn it into a separate file, which is kind of cool. So yeah, the digital nature of these things makes these things incredibly difficult, particularly this originator-controlled access control, because it's very difficult on a system to enforce things. So what are some other ways to exfiltrate data? So we just talked about this, like take a picture of it, What are some other ways? Yeah.
If this stuff isn't like encrypted on the hard drive, you can just take the hard drive out and put it into a different.
Right, so if it's
system.
unencrypted, you could take it out and just plug it in somewhere else. What else? And get raw access to the raw bits that are stored on the hard drive? Yeah.
Depending on what type of memory they have, you can take that as well.
Yeah, so you may be able to take the memory. There's actually research done a while ago that showed. Did I talk about this already? I feel like
I think so.
About the frozen.
Yeah.
Okay, yeah. So if you freeze memory, it or get it very cold, it will stay powered while it's unplugged. So you could take it out of that machine, put it in another machine. What else?
Talk to people.
You could just talk to people. You could give the information to people, right? I mean, this is how you have leakers in basically any organization, right? Is because people can verbally give you the information that's in their head, which may or may not be the information that they saw on their screen. You could retype the whole information from looking in one screen into a completely other machine. Anything else? I'm trying to remember what book it was. There was a book where they did Morse code on the computer. They I want to say, I can't remember if it was just tapping or if they turned a light into like blinking Morse code to be able to leak some data from one machine to another. People have developed systems to get around the air gap system, so systems that aren't connected to the internet. If you infiltrate that, how do you get data back out? So they'll use things like the speed of the fan to encode data, and the fan, you can hear basically what frequency the fan is spinning at. So if you change that and modulate that from another machine, you can detect that through the microphone there to extract information.
There was a heating system that they did that with too.
Heating system, so exfiltrating information through the heating system. Yeah, it starts to get into like a sci-fi realm, but this is actually all possible, which is crazy. Cool, so yeah, that's why that is very difficult. So, I want to kind of dive in here a little bit more because we've looked a lot at discretionary access control because that's what Unix uses, that's for the most part what Windows uses, and so that's kind of what we're most familiar with in our day-to-day computer interactions. So we're going to dive into mandatory access control, and we will go through, okay. Cool. I'm trying to think of if I want to, let's go get back. Okay, cool. So, in a mandatory access control system, again, the system itself is enforcing the access. So here we can have, basically you can think of the objects in our system are going to have, essentially I think of them as metadata or tags on them that give information about how sensitive this data is. And you can think of kind of three different ways. So one is at the security level. So what are the current US security levels? Anyone know for data? Or does somebody have one? Yeah.
Public.
Public? Probably. I don't know what the technical term is for that. Maybe. Is it? Yeah. Do you know? Or
I don't know, but
just
it's
adding one.
Confidential or like
Confidential.
secret,
Secret. Top
top secret?
secret. Yeah.
Sensitive but unclassed.
That's right. They're sensitive but unclassified. So there's a slight level above unclassified, and I believe things like salaries and personal information falls under that type of thing. What else? Yeah.
SRD, secure restricted data, formerly restricted data.
What are those? I actually have not heard of those. So.
This might be DOE specific, but
Mhm.
formerly restricted data is like, unclassified nuclear information that we still wouldn't want to kind of just make publicly available.
I think those we're going to get into in a second, because
Okay.
I think I think they're going to fall under the categories. I
And
think.
then restricted data and SRD are just like secret and top secret, but with some other stuff on top.
I see. Cool. Okay. So yeah. So the basic kind of levels we'll start thinking about is basically unclassified. We'll do kind of a more simplified model: unclassified, classified, secret, top secret. So what do these mean? I mean, they're just names that we're giving to labels, but what do they actually mean? Yeah.
How much damage you can do with it?
how much damage, I'd say probably how much damage in some sense, the system or the person creating these labels thinks that you can do with this knowledge, right? And so this is why we think of them in terms of levels. So you have this kind of hierarchy of levels. And so basically means that if the information at top secret if some top secret information were to leak out, that would be way worse than classified information leaking out, right? So basically, let's say you have access to, let's say, classified information. What does that kind of mean then?
Yeah,
So how would you be able to make this system actually work? Like we talked before, you have objects, subjects, like what would you do there? Yeah.
Well, I don't think you would want, just because information is like, you don't want to, these aren't the same thing as, like you don't want someone to just have access to all top secret data, right?
But
Or
why not?
Maybe
if
you
I
do.
have top secret access, shouldn't I get access to all the top secret information?
It feels like there's like some information can be top secret, but some of it won't be relevant to what you're doing.
Why is that important? Yeah. Go ahead.
Oh, I was gonna say there's a need to know aspect to it too.
Right. So why though? I mean, why do they have that aspect? Yeah.
Minimize risk.
Minimize risk, right? It's what we've been talking about of essentially least privilege, right? So just because you are cleared for classified or top secret access, does that mean you should also be able to access the nuclear launch codes, all of the nuclear secrets, as well as all of the, I don't know, information on crazy security vulnerabilities that the government has, as well as like, I don't know, alien information or whatever. Like I'm clearly out of my depth here because I don't have any of this, but so I'm just making stuff up. But it's very clear that that's silly, right? Like you don't need access to that information, so why actually give you access to that information? Which is why, but fundamentally, if we just think about it in terms of these levels, we've talked about expressivity. That's not enough to express this notion of, well, but you don't need access to all top secret information if you have access, yeah.
Maybe categorize it then?
Yeah, so then we have security categories, exactly. So, and another way to think about that is in terms of labels. They're very related here. So the idea being that you could have some data that is top secret that maybe refers to a certain category, and even though you have top secret access, you don't need access to that. Or you could think of it even at the secret level. Just because you have top secret access doesn't mean you get access to all of the secret data just because you think that you need it. Cool. Okay, perfect. And this is everything we've talked about. Like, basically for security levels, we have this hierarchy. And so somebody needs to, and this is part of actually implementing something like this and why it's much more difficult than a discretionary access control system, because somebody needs to decide for every piece of data that you have, what is the security level here? Which is maybe not trivial, right? So somebody has to decide that. On a system, you need to tag data. So we talked, okay, so cool. So we talked about we want to tag data with security levels. So the commercial security levels, if you kind of thought about it, these are, obviously every corporation can do whatever they want. You can think about public, sensitive, proprietary, or restricted information. Whereas the military has kind of another top secret, secret, confidential, and unclassified. Cool. So what's the policy? So what policy do we want for our mandatory access control system to enforce? So I'm going to draw some real terrible. So let's use top secret, secret, confidential, and unclassified. I forgot to bring my tablet today, but. So let's go here. I'm really good at this. So top secret, secret, confidential, unclassified. Okay, so what should our policy be? So we'll ignore labels for now, and and we'll just think about it in terms of just these levels, what's our policy? So the system's going to enforce it for us, and of course, so what's the military system of enforcing this?
Rank?
Security clearance.
Security clearances? What are they? Yeah.
Officer ranks?
Ranks, I actually don't know factor into this, possibly, but it's more about the level, like what level of clearance you have, but how do they actually enforce it? Yeah.
They like, I guess they like encrypt the data and they keep it somewhere in a place that most people can't access unless they have
Maybe, so
clearance.
do they need to do that? I mean, there's actually a lot of mechanisms they enforce this with. They have, as far as my understanding is, when you're using a classified or up system, it will have like a red, what's the word I'm looking for, like bezel around the screen so that you know that it's a classified system. They have special secure facilities that you can go into to access these systems that are crazy. They also, I mean, what's the penalty for violating this stuff?
Treason. Go to jail.
Yeah, treason and jail and death. So they have a pretty hardcore system to actually enforce all of these mechanisms. And of course they do a lot of things, crypto, all this kind of stuff to implement this, but they have those nice fallbacks. So how do we do this? So what's our policy?
Only people with certain access have access to local business.
Yeah, but how do we kind of express that policy? So intuitively, if we think about this, so you're at the unclassified level, what does that mean you should be able to do?
Access unclassified information.
Access unclassified information, but specifically what type of access? So so let's focus on just reading and writing here. Seem fair? Reading, writing. Cool, so you're at the unclassified level. What should you be able to read?
Unclassified.
Unclassified information?
Or like-
Should you be able to read top secret information?
No.
Secret information?
Nope.
Classified information?
No.
Just unclassified information.
Or some information unclassified.
Yeah, we'll right now just think of the whole level as one thing. So okay, perfect. So what about at the confidential level?
Probably both the bottom two.
Should you be able to read unclassified stuff?
Yes.
What about classified stuff?
Yes.
What about top secret stuff?
No.
No. What about secret?
Read everything at or below that level.
So you should be able to read everything at or below that level, right? So think of that as read down. So you should be able to read information down. So you should be able to read anything at your level or below. Right? Makes sense because everything is classified there. But now let's think about writing. So what about writing? So let's think at the unclassified level. Should you be able to write top secret information? Why not?
Because it's top secret and it was you probably weren't the one to create the top
What?
secret.
Okay, let's think about it this way. What's the security property we're trying to guarantee here? What is the military the most afraid of?
An insider threat.
Information getting out. The entire reason why we create this system is so that no top secret or classified data is released. That's what they're terrified about. So, if you have an unclassified person, can they write a document that's, let's say, top secret?
Sure.
Yeah.
Wouldn't you want everything, anyone writes to be first top secret before cascading, I guess, down?
Possibly. We'll think about that in a second, but I want to think of this general concept. Yeah, let's go in the back here.
I think it might be on the same lines.
Mhm.
If they write a top secret document and they're lower rank, but they pretty much have read the top.
Okay, so that is interesting. The idea being you can write a top secret document. Should you then be able to read that document?
Well, if you wrote it, then like you know what's in it.
I mean, you definitely know what's in it, yes.
So maybe people with unclassified like clearance shouldn't have or shouldn't be able to write top secret documents.
Interesting. Yeah. In the back, sorry.
Okay. Well, maybe they can write a top secret document, but they can't determine whether it is top secret or not. That has to be done by another individual.
Interesting. Okay, what else? What thoughts? Yeah.
Well, I was going to say, you might incidentally come across top secret information which you can't access the system, so that information would have to be put into a top secret system by somebody else.
Right, so you may not have access to all the top secret information, but you may be working on a project where you don't need any of that information, but the information you're generating is top secret, and maybe you don't even care. I mean, you can think of, it's hard to simplify this down too much to this kind of model level, but at a certain level, if you're unclassified, you should be able to just write a top secret document, and that does not violate the security properties, except that you have that information, you technically could leak it, but you are only leaking just that information that you actually created. You can't go read another document and then release it, yeah.
I was gonna say that it's like if you're an accountant and you write like a top secret like stockholder thing, that would be top secret even though you're not classified to read it.
Right, yeah.
I was thinking maybe if like an unclassified user like creates a document and then it becomes top secret, maybe then they should like change their clearance level or get their clearance level changed.
But you may, I mean, you think about the clearance level is only about what information you need to do your job, right? So if you can do your job without access to top secret information, even though you're generating top secret information, that's probably best in terms of this model, right? Because you don't need that access to any of that top secret information, and anything you produce will just tag as top secret, and that's fine. Like you're doing your job without access to that information. Yeah.
I was gonna say if you're unclassified, you don't have access to secure. Like when I was in the Marine Corps, we had different computers for different networks, so like you actually had to have authorization to get on the secure network, like the secret computers. So I don't know how you'd be able to write from an unclassified computer to a secure network without having that access there.
Correct. Let's say you hand this to your superior who goes, oh crap, this is a top secret document, and throws top secret on it, right? So if you think about this model in terms of what things you want, and what they're worried about is this part, right? Because if you have access to a classified computer, you're getting access to all these documents that then you could possibly leak. So they're making sure that if you have access to that system, you have classified access, right? Because you can access all those documents. It's not like they're restricting that in any way. But yeah, this is where the model and the real world kind of deviate a little bit, yeah.
You may also want to control access to the metadata behind that document as well. Like maybe if that person is generating top secret information, don't necessarily tell them which aspects of it they're generating is top secret.
Yeah, that actually is an interesting point too. You may want to, you may want to keep them in the dark about what is, top secret. You can say, hey, don't share this information out about what you're doing. That's probably more of a standard thing. And we'll just keep filing away everything you produce as top secret. So then the idea here is, oh, that's a bad arrow. But the fundamental, and this is kind of, there's some things that are a little bit counterintuitive about this, is in order to ensure that information can't flow down, right? So this is the key thing, is you don't want top secret information to be able to be leaked down. You fundamentally, reading down makes sense, right? You can't read up. You don't want to be able, for somebody at the classified level, to read a top secret document. But you can write up just fine. So you can write at your level or higher, and it's actually fine, and it doesn't break the security of the system. Yeah.
Shouldn't you be able to write down as well?
Should you though?
I mean, if you have secret classification, shouldn't you be able to write unclassified documents?
Yeah.
So if you're writing down, doesn't that present the risk that maybe you would accidentally put something in there?
Yeah, because you have knowledge, right, at everything at that level, or theoretically, right? If you think about it at a theoretical level, you at this classified level could have access to every classified document. So if you're writing an unclassified document, how do you actually know that you're not accidentally releasing classified information? So if you want to be, and this is part of the mandatory access control, you are willing to give up usability in order to guarantee that no information is leaked out, then those are the things that you have to do. Of course, why doesn't that work in the real world?
Emails.
I mean,
If I need to email someone else in my organization, but I have top secret clearance,
you would fundamentally never be able to talk to anybody who has a lower clearance level than you, right? Which doesn't really work. So, yes, so there's two different things. Like one is we're looking at this as a model of access control, and we're not going to go into this, but you can formalize this and you can prove things of if you ensure this property of write down, read up, you can ensure that no information will be leaked. The problem there is that's useless. Like the person with, people with top secret clearance would never be able to communicate down to anyone else and nothing would ever get done. So you need to have some way of essentially kind of lowering your clearance and being able to write information at that level. But from a information theory perspective, because what you're interested in here is how does information flow through this system from top secret to secret, classified, unclassified, and back up with people doing that. Those all through the ways that basically we specified here. So we can actually formalize all of this, and this is just, I'm going to go with this briefly because you literally just derived this. So if we have basically L is the security clearance of the subject, so subjects are who? Or what?
the things that can act in the system.
Yeah, things that can act, normally users, and now we're talking about people, users. The LO is a security classification of an object, so something in the system. And let's say we've enumerated our security classifications from 0 to K. So we have a hierarchy. Again, this is just formalizing that model that we showed. And so we're saying a subject can read an object if the security level of the object is less than or equal to the security level of the subject. This is read down, exactly what we talked about. And then this star property, and I'm calling these preliminary versions because we don't have categories yet. So when we add categories and labels to things, this is going to change, and we'll talk about that. But these are the two properties that we just derived, just written more formally. So that you can read up, so you can read an object if it's at the same level or lower. You can write to an object if it's at the same level or higher. So you can read up, no, read down, write up. Cool. See, look at, you just did this. You're teaching yourselves. I don't even need to be here.
We need someone to click through the slides.
Somebody's got to click. I think you guys could probably figure out when to click. It's not too difficult. And the problem that we talked about is now security levels are actually too coarse-grained. That's incorrect. They're too coarse. So this means that anything tagged at top secret, you have access now to this treasure trove of data of every top secret information that's ever been created. And I'm going to go fix that now because it's going to bug me. So you can do things like, and these are things I pulled from Wikipedia. So interesting thing is usually the name of the security category is not in itself top secret or classified. It's like unclassified information. But I think some of them are. It's very confusing. I actually don't. I feel a little sorry for people who have to deal with this on the day-to-day. So you have categories. You think things like nuclear, things that have to do with NATO. Do you know what ACE stands for? I can't remember. And basically, the idea is exactly this need-to-know basis idea, which we will get into. We will rederive our new security policy that does what we want on, what day is it?
Tuesday.
On Thursday.